So, I am Anjali from Group 4 and I am going to talk about Reynolds number experiment. My talk will be in different parts as what will be the aim of the experiment and what are the apparatus required, what will be the procedure, the observation result of the experiment. I'll be starting with a brief introduction about the experiment. In nature and in laboratory, experiments flow may occur under two very different regimes, laminar and turbulent. In laminar flows, fluid particles move in layers sliding over each other, causing a small energy exchange to occur between layers. Laminar flow occurs fluids with high viscosity moving at slow velocity. The turbulent flow, on the other hand, is characterized by random movements and intermixing of fluid particles with a great exchange of energy throughout the fluid. This type of flow occurs in fluid with low viscosity and high velocity. The dimensionless Reynolds number is used to classify the state of flow. The Reynolds number demonstration is a classic experiment based on visualizing flow behavior by slowly and steadily injecting dye into a pipe. This experiment was first performed by Osborne Reynolds in the late 19th century. Bhavneet, can you take to the aim, please? The aim of the experiment is to perform the Reynolds experiment for determination of different regimes of flow. And the apparatus required for experiment are as follows: a stopwatch, a graduated cylinder, and Reynolds apparatus, which consists of water tank having a glass tube leading out of it. The glass tube has a bell mouth at entrance and a regulating valve at outlet. A dye container with an arrangement of injecting a fine filament of dye at the entrance of the glass tube. Potassium permanganate to which brightly reddish color streak. Thermometer and measuring tank. And the theory contains mainly three types of flow. Laminar flow is defined as that type of flow in which the fluid particle moves along the well-defined paths or streamline and all the streamlines are straight and parallel. Turbulent flow is defined as the type of flow in which the fluid particles move in zigzag way and the fluid particle crosses the paths each other. A flow in which we can see both laminar and turbulent flow together, this flow is known as transition flow. Laminar flow changes to turbulent flow when velocity is increased and the diameter of the pipe is increased and viscosity of fluid is decreased. Reynolds was the first to demonstrate that the transition from laminar to turbulent depend not only on the mean velocity but on the quantity called Reynolds number. And the procedure to the experiment will be fill the tank with water and leave it for some time as the water in the tank should come to rest. Now fill the reservoir with a dye, generally potassium permanganate solution, which is nothing but colored fluid. The weight density of dye should be same as that of water. Allow the flow through the glass tube at a very low rate by partially opening the outlet valve of a glass tube. When the flow is stable, open the inlet valve of dye injector and allow the colored fluid to flow through the glass tube. Observe the appearance of dye filament in the glass tube and note the type of flow contained for the particular discharge. Take a stopwatch and note down the volume of water collected in a measure for certain interval of time. Repeat the above procedure for different discharge rates and calculate Reynolds number for each type of flow. Further, Bhavna will continue.
So we will talk about the observations. At low velocity, we will observe that the dye will move in a line parallel to the tube and also it does not get dispersed. And when the velocity is increased a little more, the dye moves in a waveform. And at more velocity, the dye will no longer move in a straight line, that is turbulent flow. Reynolds number when the conditions are given for like when the flow condition is laminar, the Reynolds number should be less than 2000 for flow in pipe, and for open channel flow Reynolds number should be less than 500. For transition flow Reynolds number should be between 2000 to 4000 for pipe flow, and for open channel it should be between 500 to 1000. And for turbulent flow Reynolds number should be greater than 4000 for pipe flow, and for open channel it should be greater than 1000. Now further, Bhavneet will continue.
And now we will cross-check the observed conditions by using the mathematical formula. And there we, first of all, for laminar flow, Here we use the formula Reynolds number that is equal to Vd over mu. And first we note the diameter of the tube used and the length of the tube, and the volume of the water collected, that is basically the discharge, and the time taken. And then for calculating the Reynolds number, we have to know the velocity rate of the water. So here for calculating the velocity, uh, we are using this q into a, and here we calculate this. And for laminar flow, we calculate the Reynolds number. And then similarly, we do the same with the transitional flow. Here we also use the same formula and derive the Reynolds number for the transitional flow. And then we last calculate the same for the turbulent flow. uh, Here we use the same formula, only the volume, that is the discharge of the water, and the volume of water collected will change. The rest of the things will remain same. So here the basic results for all the three: the Reynolds number for laminar flow, transitional flow, and the turbulent flow. And next, the Abhay will continue.
So now the precautions for the experiment are: take reading of discharge accurately, set the discharge value accurately for each flow, and the experiment should be done at suitable and unshaken place. Thank you.